Hi, this is Sri from Techie Talks AI. Welcome everyone to the database evolution tutorial. Today we will walk you through how data storage has evolved from traditional relational database to NoSQL and finally to vector databases, the foundation of AI-powered search. We'll see different use cases, and we have created a very nice project where a single endpoint can be used to access different types of data as per our need. Hi, welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we showcase hands-on demos and insights into AI automation and no-code tools. We have created several make.com modules to simplify no-code automation for you. Subscribe and join us on this journey into the future of technology. We will use a single Docker Compose setup that ties together SQLite, Redis, and PostgreSQL with pgvector, all managed to a single FastAPI backend. So why this tutorial? Every type of database solves a different kind of problem. Relational database like SQLite give us structured, reliable, and strongly consistent data. NoSQL databases like Redis provide incredible speed and flexibility when structure is not fixed. And vector databases such as PostgreSQL with pgvector extension enable semantic, AI-driven search that understands meaning, not just keywords. This tutorial helps you see all three running side by side, understand their use cases, and learn how modern systems use them together. Relational DB, SQLite. So SQLite is one easy to test example that we have selected. You can use any other SQL database. Let's begin with SQLite, a lightweight file-based relational database. It follows a strict schema with tables, columns, and data types. Every record must fit into this structure. And SQL queries let us filter, join, and update data with precision. Relational databases are perfect for transactions, accounting, and core business logic, where data integrity matters. In this project, you can test it using endpoints like SQLite/items. We will see that. We will also see CRUD operation, that is create, read, update, and delete operations. It is simple but powerful and ideal starting point. NoSQL database, we will use Redis as a simple example. We can use other databases like MongoDB, etc. or AWS DynamoDB. Now we move into Redis, which represents the NoSQL family. Unlike relational database, Redis doesn't require a schema. It stores key value pairs directly in memory. This makes it lightning fast. Redis is great for caching, real-time analytics, message queues, and even temporary document storage. In this tutorial, we'll show both styles. Simple key value through Redis/kv and small document style storage using /Redis/doc. This demonstrates how flexibility and performance come together with NoSQL databases. Vector database. For vector database, we will use PostgreSQL pgvector extension as an example. Finally, the modern frontier vector databases. Here we use Postgres extended with pgvector. It allows us to store embeddings, numeric vector representations of text, and perform similarity searches. Instead of exact matches, we can find conceptually similar items. For example, when you search for Python Web API, it can find documents that talk about FastAPI, even if that phrase never appears literally. This kind of search powers chatbots, recommendation systems, and semantic search engines. You can try it using /vector/docs to add documents and /vector/search to query similar ones. We will see that. So the project architecture overview, let's see how it all fits together. FastAPI as a single entry point, a unified API service. Docker Compose orchestrates three containers, SQLite and Postgre with pgvector. Each one exposes specific endpoints handled by FastAPI routes. The API automatically waits for databases to start and initializes tables and extensions on startup. In short, this architecture demonstrates a multi-database microservice-friendly setup, perfect for education and production prototypes that are scalable. Testing each layer with curl. The best way to understand this system is to test it directly using curl. Create and list items, SQLite/items, set and retrieve keys /redis/kv and /redis/doc. We will see this. Add and semantically search vector embeddings /vector/docs and /vector/search. Each command can be executed directly in our terminal. So you can see how each database behaves differently in response to same kind of operation. The future of data. The future of data is hybrid. Real-world applications no longer rely on a single database type. Instead, they combine relational reliability, NoSQL performance, and vector intelligence. Imagine a workflow like this. Use and order data in relational database, session data and cache in Redis, semantic recommendations powered by pgvector. That is exactly how AI-enabled platforms work today. And with this Docker Compose stack, you now understand the foundation of that evolution. So link to the lab code is given in the description. So Docker Compose up --build will start the project stack. That is SQLite, Redis, and pgvector. If you browse the Swagger endpoint of this FastAPI, we will see all the endpoints which are exposed. Okay, so SQLite items with item ID, and then Redis section which stores key value, and then pgvector. But instead of testing it through this UI, we will use curl command to test it. Currently, if you see the SQLite items, you will notice that there are no items in the SQLite database. We will use curl to add items. So we will use curl post localhost /8000 /SQLite items, and we provide the item pen, description blue ink pen. So we'll execute this command to insert one item into the SQLite database. So we are testing CRUD operation. Okay, so I'm executing this. See, one item has been added into our SQLite database. Let's see the Swagger to see if the data is visible. Yes, see, one item ID 1, pen, blue ink. We will also add one more item, red ink, and execute. You will notice red ink also has come. Let's execute curl command to list the items. We will use this command, SQLite items, without any parameter to list the items. See here, blue ink, red ink. So this is simple CRUD operation to test our SQLite database. We can also access data using the ID of the record. So here ID 1 should give us the blue ink record. ID 2 should give us the red ink record. So create, read, and update. We will see how update can be done. So for update, we provide the ID of the record here. We are changing the name to marker and description black permanent marker. Let's execute it. Okay, so let's list items. See here, record 1 has been updated. And in this Swagger also we can list the items and see black permanent marker ID 1. Next is delete. So let's delete it returns OK true, and if you see, ID1 has been deleted. So that is CRUD operations on a SQLite database. Next is Redis NoSQL key value store. So we will have two examples where we'll store key values and also a document. So first, let's create a key called greeting with a value hello world. Okay, we got true, and in the, so here keys should list the keys. See, keys greeting, and here let's execute this, and we will provide the key name greeting to see if we can get the value. See here, greeting hello world. We will test this using curl. So here, this will get the keys value. Okay, see, greeting hello world. Next, let's list the keys. We only have one key, but let's see if listing works. Yes. There is also a pattern that we can pass. Pattern equal to doc colon star or whatever string you specify, it will search based on that. Here we will upload a document. Document ID A1, title, reminder, body, drink water. So this is a sample example of how a document can be uploaded. Okay, so it returned true, and let's get the, so here we are able to get the document back. Document ID we are passing A1. So this is similar to key value pair, but here it is a multi-value structure. Next is PostgreSQL. So we will add vectorized document. We are adding one string. FastAPI is a modern Python web framework. We are adding that. So this is going to be converted as embeddings and saved in our vector database. One more, Redis is an in-memory data store used for caching. Our second document. And third, Postgres with pgvector enables semantic search. So that is our third document to be saved in our vector database. Okay, so now what we will do is we will see the stored strings. There are multiple ones because I tested it just before recording. Okay, so now we will do a similarity search. Okay, we are searching Python Web API. See here, our text is Python Web Framework. What we searched was Python Web API. Similarity, it did cosine similarity and gave us two results. Now this is the main.py that is exposing all the FastAPI endpoints that we just saw. SQLite items. So these endpoints get hit depending on the type of HTTP method that we use. If you use HTTP post on SQLite items, this function gets called. If you use get and SQLite items endpoint, this method gets called. And the method also changes based on the parameters present or not. So if item ID is present, this method gets called. And if it is put with items ID, this update gets called. Same way, if the method is delete, this gets called. And here we have the key value pairs for Redis and then vector database. Here we have the vector database endpoints, and it uses this hash embedding to create embeddings for our text. So this embedding uses 384 dimensions. Thanks for watching. Please like, share and subscribe. Your support really helps. Have ideas or suggestions? Drop them in the comments. Let's build together. At Shogini, we offer expert nocodemake.com and Python AI automation consulting with ready-to-use modules to jumpstart your projects. Stay tuned and subscribe for more.